Welcome to Saraswati Skill Programs. This session is on how aircraft flies. This is in two parts. Part 1 is about how aircraft flies. Part 2 is about on aircraft controls. Aircraft from the past to future, if they consider, it is worth consider aircraft industry how it has evolved from 1903, where Wright brothers has done experiment at Kitty Hawk, to the present day modern aircraft and future aircraft, blended aircraft. So there is a lot of technology development has happened in the aircraft industry over last 100 years. Recently, the largest aircraft flight has happened in August 2016. In relation to that, this session is to discuss on how aircraft flies. So before going to actual aircraft flight, it is worth to consider a piece of paper, a general standard experiment, science experiment, where a paper is taken and air is blown over the surface of the paper. There is a tendency and it lifts the paper up. So this has been demonstrated through experiment by a couple of students. See, as the air is blowing on the upper surface, this is lifting up. So this means here the pressure is more, on the top side pressure is low. That's the reason this drooping paper is lifting up. Similarly, it is irrespective of the person, the same concept is repeated. As the person is blowing the air over the piece of paper, it is lifting up. So the same principle is applied in the aircraft. This we will see in this session. So courtesy to Sri and Arjun on sharing this video for this session. If the same simple paper is to be lifted, air is blown over the paper. But if you see aircraft to be lifted of 100 tons in the nature, there is a lot of amount of lift force is required. It has been seen from the different aircrafts like Airbus, Boeing, Bombardier, McDonnell, and Tejas. These are order of the tons. To lift this aircraft, it is required so much force is required, so that it can be seen how it is evaluated. So before going to the actual discussion, how this actually aircraft in the industry, so let us see how the atmosphere looks like. So atmosphere is full of the air. It is consist of 21% of oxygen, 78% nitrogen, and 1% of other gases. So as this image shows that there is a how this atmosphere is filled, like you're starting from the troposphere, stratosphere, mesosphere, and thermosphere. Then the aircraft operates in the troposphere, which is around 20-kilometer range from sea level. So this is taken from the so and so in the internet regarding this image. Then at atmosphere, the air pressure is at 1 at 1 3 to 5 Newton per meter square. To lift such a large weight aircraft, so much area is required. So that's why this wingspan is more in the aircraft. So let us see. So what are all the forces required to lift this aircraft? That is, one is aircraft mainly operates on the four forces. That is lift, that is which is the lifting the aircraft. Drag is opposite to the like forward direction or whichever is opposite to the motion. thrust is which is the responsible for moving of aircraft in forward direction. Weight is its total gravity force. The steady plane, so where the lift is equal to weight, thrust is equal to drag, then aircraft moves with the steady uniform velocity. To do this aircraft lift principles, let us take how a simple experiment of a variable cross-section pipe, like let us similar to the venturimeter, how air flows through different sections, what exactly it's as per the energy theorem. So total energy in the as per the continuous theorem on Newtonian fluid, as per the total energy at each section is constant. So let's take a section of the at this one, two, three sections of this variable pipe. So whatever the energy at this level, whatever the energy at this level, whatever the energy at this section is same, but only it is a varies. This energy at level is consist of pressure energy, velocity energy, and its potential energy. So total energy is constant. So as the flow is approaching in this direction, here the pressure energy decreases and velocity goes up. So same principle we will see in the present scenario. Quantitatively, if you apply the same principle to the variable cross section, either taking off 52 meters per second, like a mass fluid with 52 kgs per second is like quantity of mass. If it is with that much pressure of 101 like sea level pressure, and with this velocity, as it goes, if you apply the continuity equation and the Bernoulli's equation, so here, so there is a variation in the pressure drops and velocities shoot up. So the same philosophy is applied. So then if we apply the, if the our section is in this direction, at this location this velocity is more, and it is in this direction as per this streamlines. So because of this at the downside, if you say the section of this nature, here is a flat nature, here is a that contour. So here is about the normal pressure, or pressure is higher than this place, so then there is a possibility of the force is generated in this direction. As pressure always pointing towards the surface, but as the pressure is low, it is away from the surface, it lifts surface in this direction. This is nothing but producing the lift. So generally the same terminology we can be given as a like aerofoil section, whatever the section in the previous section is there. So this can be modified to aerofoil section. So there is a aerofoil section is a cap shape capable of producing lift with relatively high efficiency. So it is having a certain terminology like a chord line starting from this point to this point, and a camber, and upper surface, lower surface. And these aerofoils are two types. One is symmetrical aerofoil. So in asymmetric aerofoil, symmetric aerofoil is having a similar kind of lift characteristic on both sides. And whereas the asymmetric aerofoil, there is a upper surface having more lift characteristics. That is advantage for fixed wing aircraft. Let us see that how this can generate this lift, this asymmetric as with different angle of attack. Angle of attack means that the way the air is impinging on that, the way it is this with respect to the cart line. So there is nothing but angle of high angle of attack will give higher lift. This can be demonstrated through this simple like animation. So here it is a more curvature, there is a more lift, that can be seen how it is possible. So now the question is how airflow will follow the contour of the airfoil. In the airfoil section, it can be seen that this is having a more curvature as compared to this lower surface. As the air impinges here, it's split into two parts, so upper surface and lower surface. So as already discussed in the previous slide, so as that there is a velocity gradient, there is a velocity streamlines in this direction, the same velocity gradient it goes. So it should, strictly speaking, this velocity should go in this direction, but it will follow in this direction. The reason is, one is this is having a boundary layer and viscosity. This at this zone, these particles comes to zero velocity and sticks to the surface, and at the same time, in case of a curved surface, it will follow the contour. Second is here uh, away from the surface there is a normal pressure. At this the pressure is low, so that means there is a tendency that there is a pressure gradient in this direction as well as a pressure gradient in this direction. So this pressure gradient will give accelerated fluid in this direction. This pressure gradient will give pushing the fluid in this direction. So that's why there is a these streamlines will bend in this direction. So that will have when the movement when the air, any fluid with the mass changing its direction means there is a force in that. That force is responsible is a centripetal force. It will push us toward the center of curvature of this session. So that's the reason a fluid with this velocity and pushing towards the curvature will follow this contour of this shape. So that's the reason aircraft in the airfoil upper surface or maybe whichever is having more curvature, so it will have a um, like a curved direction and bend the flow, bend the streamlines. So this is centripetal force is one of the main responsible to bend this, pushes this towards this trailing edge to follow the contour. And at the same time, so when the it is taking the turn, it will pushes the mass with a different velocity, a certain velocity in this direction. So this is nothing but a downwash. So this will have like as per the momentum principles, it have mass into velocity, it have a force. And as this is like a shear of this parallel to the surface, at the same time as per the Newton's third law, it will push this airfoil in this direction. Either you can take this as a like a reference frame or you can take this as a reference frame. Both have a relative velocity. That's why this aircraft uh, is moved in this direction. Or in other words, as per the previous Bernoulli's theorem, as aircraft is as as velocity is increased in this direction, there is a pressure gradient. So more fluid is pushed this side. So that means this is going in this direction. So with these two main reasons, one is Bernoulli's law and the other one is this momentum principle, Newton's third law. This the lift is happening in the aircraft. So there are many theories responsible for this lift. However, this is our understanding as the curved surface, the Coanda effect, the surface boundary layer. There are many things are also responsible to do this. So these images are taken from the some of the internet. So you see there is a velocity gradient. That gradient will follow, and with this velocity, it will come out of this like aerofoil trailing edge as in the form of a downwash. So that will give a reactive force on this aerofoil. It will push the aircraft. That means, in other words, it lifts. So the same principle can be applied. The same principle uh, the same principle can be applied to the real aircraft. So where the lift is happening in this aircraft flowing direction and this airflow direction. So that will create some kind of a pressure distribution in this as per the discussed. So this is the lift force. This can be seen in the form of a demo. So as the aircraft is these flow lines are bending this side, and the more curvature, the more bend is there, and it is responsible for the lift. And these images are be taken from the net, and this is like a simulated like animation has been like a drawn to simulate this like lift. So lift is another factor where it is mathematically is like a density into velocity square by 2 into the surface area. The moment they are having more surface area of the wing, which is having more lift, at the same time as angle of attack is more, so there is a lift force is more, but it is only up to certain critical angle of attack. So we'll see in the later sessions how it can be as more angle of attack, how it is having a detrimental flight. So this rho is the density of air and the surface area and velocity of air. So finally the lift force is is needed to lift the weight. So weight is mainly responsible to have a like more like airframe and passengers and fuel of this aircraft will contribute the weight, and it acts as center of gravity. And this is to demonstrate this live example has been captured to see that how that lift is happening in this scenario. See, as it goes up, there is a like a lift is operating in this direction, and to do that lift and weight, there is a thrust force also required, because here, as in the aircraft, it is not only lifting, it is going in the forward direction that is responsible by this engine thrust. So it will pushes this aircraft to the forward direction. So this is nothing but this in this direction. The exhaust gases will push here. Similarly, same relative velocity concept, relative Newton's third law. It will, as the excited gas pushing this engine will move in this direction. In turn, the aircraft will move. So, there is other factor which reduces the like its performance is drag. So where it is opposite to that movement of the aircraft in the for the lift as well as thrust. It depends upon the speed, shape, and density of air, if any obstructions in the flow. So the drag is also similar to a lift formula mathematically. This half rho v square into surface area into quotient of the drag. So this mainly influences as angle of attack, compressibility, Mach number, Reynolds number, and viscosity effects, and geometry of the this section. So in the nutshell, this is the basic concept of like the lift, how it will happen. Uh, the, as discussed, the main concept of strategy also can be applicable, where this is a science application with rational thoughts skillfully to the requirement of industry. Will with that approach, it is easily understood how things works. Similarly, how aircraft flies can be understood by application of science with rational thought to skillfully to the requirement of industries. To do this, there are some of the references has been taken from the YouTube or like Wikipedia and like the textbooks and industry tips. Thank you.